So we'll take our very quick look at the calendar. Today we're going to talk about slope. Most likely you've seen slope in some previous math class, but if you don't know what it is, that's okay. Monday coming up, we'll talk about equations of lines and something called slope-intercept form. And then Wednesday coming up is our very first quest, which is like something between a quiz and a test. It is a full period assessment. So we're not doing anything on Wednesday except for taking this quest. I want to point out that the material covered on this quest is classes 1 through 5, and you can see the 5 right there, is today. So today is the last day of new material for that quest. Monday we're going to do some new stuff that isn't on the quest, okay? You'll notice that there isn't a review day built in here right before the quest. So Monday is a regular day for us with new material, and then Wednesday we're just taking the quest. So between now and Wednesday, your job is to find some internal motivation and study for this thing. And I think that we found, didn't we find the practice quest problems in the packet last class? Again, if you wanted to take a quick look, they're on page 33. So there's like an entire practice quest basically on page 33. And as I mentioned before, there's an answer key in the packet. If you go onto Moodle, you'll find full color solutions written up in a PDF. And if you go onto YouTube, you'll find videos of me going through each of these problems step by step, okay? So we don't have a review period, but you have all of the resources you could possibly want for in terms of practice problems for this quest. Julia. Are you talking about for this sample quest? Yeah, so there's a couple of ways to find the videos that I make. One of them is to type in exactly the right title on YouTube, and the right title for today's class is 0962014 September, and then today is the 12th. No spaces. So that's how you find the class video for today. Iman. 03. Always a 2-digit date. Other questions? If you go on Moodle, you'll find playlists for the videos that we make in class and another playlist for the sample test problems. Okay, so at the top of page 22 is where we begin. Can we start with Jasper? Daily summary. Mm-hmm. Okay, thank you. Number 1, Sam.
Portion of road B on 795 feet over 4 long within 3,325. Which road is steeper? There is all labeled diagram of the situation. Road complete and fire.
Okay, thank you. All right, so we've got this information about 2 roads. So we're going to draw road A, which says it climbs 120 feet over a horizontal distance of 4,250 feet. So let's say that that's my horizontal 4,250. And then it climbs 120. Now it's kind of difficult to draw this to scale, but 120 is sure a heck of a lot less than 4,250. So I'm going to draw something much smaller. And then the road itself is this kind of diagonal thing here. So there's your 120 is the vertical, the rise, and then the horizontal is 4,250. So that right there is road A. And then we can do the same kind of thing over here for road B. Here it says it climbs 95 and the horizontal is 2875. Again, I'm going to do my best to do things to scale, but it's tough. 2875 is about 3/4 of this 4,000 number here, so I'll draw something that's maybe about 3/4 of that length over there. And then the 95 again is a really teeny tiny amount relative to the big horizontal. So we've got 2875 on the bottom, 95 vertical, and then the diagonal road there. And that's B. Okay, and the question is which one of these is steeper? And certainly you're not going to get any information from my drawings because I can't draw them to scale. But there's got to be some calculation we can do with these pairs of numbers, right? The 2875 compared to the 95 and the 4250 compared to the 120. And the natural thing to do, I think, is to divide these numbers. If the blue picture over here, maybe the horizontal is like 100 times the vertical, just throwing out a number that isn't right. And over here, maybe in the red picture, it's only like 80 times the vertical, then I could tell which one is steeper. So division, I think, is the right thing to do. You have two choices. You could take the 120 and divide by the 4250, or you could take the 4250 and divide by the 120. Both of them can get you the right answer, but I'm going to force us to use one of them because today we're talking about this thing called slope. Slope is rise over run. So we're going to do which one on top? The 42, we're going to do that 120 on top. So let's write here the information for the slope of A. I'm going to write rise over run. We'll see that formula in just a moment. But the rise is supposed to tell you we're doing a vertical thing, 120, over the run, that's the running horizontally, 4250. If we can get somebody with a calculator to type that in, that would be great. 0.028. Okay, and then we'll do the same thing for B. Still rise over run. So which number goes on top? 95. The rise, the vertical part. And then downstairs is the run. Sam, what is this? Okay, so what that means is that in the red picture, the vertical is a bigger part of the horizontal because it's a bigger decimal. If you want to think of things as percentages, the blue number is what percent? 2.8, yes? Go from a decimal to a percent, we move that decimal point twice, exactly twice. So the blue thing is a 2.8%, the red thing is a 3.3%. What this means over here in blue is that the vertical is 2.8% of the horizontal. That's what that 2.8 is, right? It's 2.8 out of the entire horizontal, and the other one is a bigger percentage of the horizontal. So which one is steeper? It's the red one, it's road B, because that's a bigger number over there. So we'll write our conclusion, although I don't have any room at the bottom, so I'm putting my conclusion at the top. Since the slope of B, which was 0.033, is greater than the slope of A, which is 0.028. Road B is steeper. Yes, Ashlyn. You don't need units, but if you wanted to, you could put them. What would happen? Let's see. So the 120 is in what units? It's a rise. What were the units for that distance of 120? It was feet. And down here is feet. And so if you put them, they happen to cancel in this case, but right, there's going to be an example that we'll do right down here where we definitely want to include units. I don't need you to put them in calculations. Yeah. Okay, any questions on that one? Typically, we won't write it as a percent, but I brought that percent in just to make a concrete decimal is usually what you put for slope. And you might have seen road signs on like steep downhills or steep uphills where it'll say like 5% grade or 8% grade, and it'll actually have like 8 and then a percent symbol in the grade, and that's exactly these numbers. It's these slope numbers just written as percentages. Okay, so let's go to number 2. And we'll go back to the other Sam at our first table. Go ahead, Sam. 2. Okay, thank you. So we've got a bunch of different ways to think about slope. We use the letter M, that's standard. It's the change in the y coordinate over the change in the x coordinate. We didn't have coordinates for those roads, but we're about to have coordinates for this pictured line down below. And then in shorthand, that Greek letter delta usually represents a change in. So it's a change in y over change in x. And then rise over run is how we started. So let's go to Samantha for 3. Okay, so we've seen this equation before, and I think that we've graphed this line before. So what we had here, as you went to the right, was time was passing, and what was happening with the hot air balloon? It was coming back down to the ground because the altitude was decreasing, right, as we ran along this graph. And so part A says choose any 2 points on the line to compute its slope. Yeah, it does. I'm going to pick not intercepts just because we don't always have the intercepts readily available. But when we say pick any 2 points, we're really not telling you the truth because I don't want you to pick that point. I want you to pick points where it's easy to just grab off the coordinates. And if you wanted to grab the coordinates here, you'd have to really start estimating. Maybe it's 0.3 and I don't know, 740. I mean, like it's hard to know, right? And so when I say any 2 points, I really mean 2 that you can really read off the grid. So for example, Sam suggested this point, which has what coordinates? 0 and 800. That's a good point right there. And then I would say that this next one right here is the next point that you might grab because it's right on the grid. And so it's easy to read this as 1, 600, right? And grab that one if we wanted. 3, 200. Okay, so here's what we're going to do. We're going to find the slope of this line, and we're going to use those 2 points. So here's how we do it. What letter do we use for slope? M. M equals. Okay, so I'm going to write some symbols here. It's easier with practice. That triangle-looking thing is a Greek letter delta, and it stands for a change in. And so what we're going to do is we're going to find the change in y. So looking at those 2 highlighted points and only focusing on the y coordinates right now, I'm asking you for a change. By how much does y change? It changes by 400. Yes? It goes from 600 to 200. That is a change of 400. So when we say change, what mathematical operation are we really talking about? It's subtraction. Yeah? Change is it's naturally subtraction. So I'm going to write the details here. I'm going to write 600 minus 200, just so we really see where the numbers come from. Divided by, and now it's a change in x, and it's another subtraction. So I'm just going to subtract down here as well. But this is one of the 2 most common moments where you might make a mistake when you calculate slope. You could do 3 minus 1, but that's wrong. What should we do? 1 minus 3. There's an order that you have to be consistent about. Upstairs, we chose to do the 600 first. If you do the 600 first on top, then you better do the 1 first on the bottom. Whatever you choose to do first on top, you have to do first on the bottom. Left to right is fine, but it actually makes, you could go right to left if you wanted to. You just have to be consistent. So once you make a choice on top, make the same choice on the bottom. So we chose this to be our first point and this to be our second. You could absolutely choose the 200 first on the top, 200 minus 600. And then downstairs you would do 3 minus 1. And you should be able to convince yourself you'll get exactly the same thing, because all that's going to happen is the signs are going to swap. It is. If there's motion involved, then the sign is indicating a direction. So let's talk about part B here. Any questions on the slope calculation? I mentioned there's two typical things that students get wrong when they calculate slope and make a mistake. One of them is to not be consistent when they subtract on top versus the bottom. The other common mistake is to accidentally put the x's upstairs and the y's downstairs. And so I don't really have any like justification for how come we always choose to put the y's upstairs, but it's just something you need to incorporate. It's the definition of slope. It's a y on top and an x on the bottom. One more thing to say about that quest coming up. So some students ask if there's like a formula sheet or if you can bring in a reference sheet, and sadly the answer is no to both of those. So this is one of those that you just have to practice with it and get comfortable saying, oh yeah, the y's are always on top. Yeah, Kiara. I'm pretty sure I'm consistent about not having formula sheets for the whole class. Julia? On some quests, yes. On other quests, no. On this one, I forgot. Ask me again on Monday. Okay. That is never a possibility. That is a big no on phones as calculators. Yeah. Okay. Part B. Part B says, what does the slope mean in this situation? And we're going to write a sentence in plain English. And Nate, I think, kind of got us partway there with this sign giving us information. But I want to come back to, I think it was Ashlyn who asked about the units. I think that putting the units in for the slope calculation can oftentimes help you really understand what the number means. That negative 200 means something very specific for this balloon trip. And putting the units in helps. 600 and 200, what were the units for these y values? These are feet, right? That's the vertical axis, is the altitude in feet. So upstairs is definitely feet. That was a change of 400 feet. And then the 1 and the 3 were in minutes. That's the horizontal unit, right? Time in minutes. So this is feet on top, minutes on the bottom. Even though the fraction part disappeared, just happened the numbers worked out that it became an integer at the end, negative 200, it's still feet on top, minutes on the bottom. There's a very small three-letter word that we're going to use to represent this division line that's really going to clarify things. Per. Feet per minute. Negative 200 feet per minute. And once you get those units up there, the sentence pretty much writes itself. You just have to copy a few of the other words from the beginning part of this problem. What's happening? The balloon's altitude is changing at negative 200 feet per minute, or the balloon's altitude is decreasing at 200 feet per minute. So let's try that. Balloon's altitude is decreasing 200 feet per minute. Yeah, there's definitely an end to this particular, like the equation of this line is only valid until we're 4 minutes in, but you don't even need to incorporate that. That's the interpretation of the slope. What if it had been a positive number instead of a negative 200? Balloon would be rising. What one word would change in my sentence? Decreasing would become increasing. Right? I mean, like anything you can measure is either increasing or decreasing. If it's changing, it's increasing or decreasing. So use one of those words. One little thing, I don't know how picky I might be about this, but if you said, yeah, actually I do know how picky I would be. I'd be pretty picky. If you said decreasing at negative 200, you would not get full credit for that sentence, right? Because the word decreasing captures the negativity of that number. And so if you use decreasing and negative, in some sense they cancel each other, and I think you could argue that this would be saying the balloon is rising, which it isn't. So just be careful about that sign. Okay, activities start on the next page. I'll walk around and help out.